Many A-level maths students left this entire question completely blank in their exam in 2022. Only the strongest students were able to answer part 2. Would you be amongst them? Part 1 says, find the value of this infinite sum that starts from r equals 4 for 3 marks. I really recommend that with a series like this, that you write out the first few terms so you can get an idea of what the sequence the series is doing. Then you can classify it as geometric, arithmetic, or maybe some other kind of series. So here, starting with r equals 4, replacing the r here with 4, and then with 5, and then with 6, and so on. So this is our first term, this is our second term, this is our third term. Can you see how we can get from our first term to our second term, and from our second term to our third term? Well, notice what's happening to the power here. The power's going up by 1. So that means to go from the first term to the second term, I'm multiplying by a half. And to go from the second term to the third term, well again, I'm multiplying by a half. So this is a geometric series, with this being our first term, we call that a. If you simplify this in your calculator, you get 5 over 4. And the common ratio r, what we're multiplying each term by to get the next, well that's a half. If you go into the mathematics formula booklet for Edexcel, you'll find 2 formulae for geometric series. You'll find this formula, which sums a finite number of terms n, the first n terms, and you'll find a second formula which sums infinitely many terms. And that's what we're going to have to use here, because we've got infinitely many terms, as you can tell from the infinity at the top of the sum there. But notice that this formula can only work if the value of r is of size less than 1. In other words, if r, the common ratio, is between -1 and +1. And the good news is that yes, r is a half here, which is of size less than 1, so it is valid to use this formula. So all we have to do is substitute a is 5 over 4 into this formula, and r is a half into the formula. If you do that, you get your first couple of marks, and then if you simplify this to get 5 over 2, you get the final mark. Part 2. Show that this equals 2 for 3 marks. In a show that question like this, what we want to do is take the examiner step by step through the working, turning one side into the other side step by step. So starting with the left-hand side, let's try and turn the left-hand side into the right-hand side, into 2. Well, first of all, let's use the definition of a sum. Notice that this sum starts with n equals 1 and ends at 48. So we sub in n equals 1 into the formula to get the first term. Then we sub in n equals 2 into the formula. Then we sub in n equals 3. And we keep doing that until we sub in n equals 48, and the one before that would be n equals 47. Notice I've left a little gap in the middle with plus ... plus to indicate that there are more terms in the middle there. If you write all of that out, you get your first method mark. Next, we can simplify each of these. This is 3 over 2. This is 4 over 3, and so on, until we get to 50 over 49. Now we're adding logs of the same base. They're all log to the base 5. When we add logs together, we can combine them into a single log by multiplying these arguments. So if we multiply all of these arguments together, we can then combine this into a single log, base 5. Notice here that a lot of cancelling happens. This 3 will cancel with this 3, this 4 will cancel with this 4, and this 5 would cancel with a 5 here that I just haven't written. And that pattern would continue. Hopefully you can see that there would be a 48 just before here, this 48, I haven't written the 48 on the top, but there would be one there, and also this 49 here would cancel with 49. So there's only 2 things that are left here, the 50 on the top and the 2 on the bottom. So this simplifies down to 50 divided by 2, which is 25. What is log to the base 5 of 25? Well, it's really asking us a question. It's saying 5 to the power of what number gives me 25? Well, it's not 5 to the power of 1. 5 to the power of 1 is 5. It is 5 to the power of 2. 5 to the power of 2, 5 times 5, is 25. So here, this whole thing equals 2, which is exactly what we have on the right-hand side. If you get that far, showing every step clearly, not skipping any big steps, and writing it down in a clear way, you get the final mark. In their reports after the exams, the examiners said that this question was found challenging by many candidates. They said the most successful candidates were the ones who followed my advice here in the video and listed the first few terms of the series. Then you can work out what kind of series it is it arithmetic, geometric, or some other kind of series, like we had in part 2, and do something sensible with it. But they said that there were, however, many attempts that made no credible progress, and a significant number of blank responses to either one or both parts of this question. They said only a few candidates produced a correct solution to part 2. Some candidates incorrectly assumed an arithmetic series and attempted to find its sum. A few candidates incorrectly assumed a geometric series and attempted to find its sum. Some candidates who made no credible progress, in other words got 0 marks for that part, resorted to listing their terms of decimals or attempted to add all 48 terms as decimals. Oh dear. If that question came up this summer, how many marks do you think that you would gain? Let me know in the comments, and let me know if there are any questions that you'd like me to review in a future video.